In this session, we shall go through some more special problems in definite integrals. You consider I1 is equal to integral 0 to 1 minus x power 50 whole to the power of 100, and I2 is equal to 1 minus x power 50 whole to the power of 101. You consider the two integrals. He has asked to find the value of I1 by I2. What is I1 by I2? See, if you look at both I1 and I2, they're almost similar except the exponent, that is here it is 100 and that there it is 101. Well, let us try to get it simplified. Look here, I2 is equal to integral 0 to 1 minus x to the power of 50 into 1 minus x to the power of 50 whole to the power of 100. Am I correct? I think you could have caught what I could have done. 1 minus x power 50 whole to the power of 101 has been split into two parts. Now, you observe this is integral 0 to 1. 1 into this is 1 minus x to the power of 50 whole to the power of 100 minus x to the power of 50 into 1 minus x to the power of 50 whole to the power of 100 dx. Well done. You observe, what is this first part? Is it not I1? Therefore, this is I1 minus integral 0 to 1 x to the power of 49 into x into 1 minus x to the power of 50 whole to the power of 100 dx. Can we write like that? We are able to write. So that this I1 minus integral 0 to 1 x to the power of 49 into x. Let us consider this one particular integral separately. Let 1 minus x to the power of 50 is equal to t. 1 minus x to the power of 50 is equal to t. Implies minus 50 x to the power of 49 dx is equal to dt. Minus 50 x to the power of 49 dx is equal to dt. Just a minute. From this, x to the power of 49 dx is therefore minus 1 by 50 dt. Everything is okay. For this 1 minus x power 50, we write t. For x power 49 dx, we write minus 1 by 50 dt. How do you have in the place of x? What should you write? Also, 1 minus x to the power of 50 is equal to t. Therefore, 1 minus t is equal to x to the power of 50. Therefore, x is equal to 1 minus t whole to the power of 1 by 50. 1 minus t whole to the power of 1 by 50. Isn't it? Well, let me, you follow up to that extent. I would like to remove this. We shall repeat it once again. Let us first have integral 1 minus x power 50 whole to the power of 100 into x to the power of 49 dx. First of all, let us first calculate this simple integral. This is equal to, this is 1 minus t whole to the power of 100 and 1 minus t whole to the power of 100 into minus 1 by 50 dt. So this is 1 minus t whole to the power of 101 by 101 in by minus 1 into minus 1 by 50. I am calculating without the limits, so that it is 1 minus, what is t? Let us consider just minus x power 9 as t. This is 1 minus x to the power of 50 whole to the power of 101 by 101 into 50 is nothing but 5050. Isn't it? Now we shall make use of this in integrating this using by parts. That is the next part. Therefore, if you name this equation 1 implies I2 is equal to I1 minus x into 1 minus x to the power of 50 whole to the power of 100 into x power 49 dx between the limits 0 to 1. Let us make use of this as integration by parts, so that this is I1 minus, come on, f of x into integral g of x, that is x into integral of that. You see, I have taken x to the power of 50 as t, 50, so this is 1 by 50, hence this is x into x power 50 as t we have taken, so that this is minus of minus becomes plus, so that it is 1 minus x to the power of 50 whole to the power of 101 by 5050 minus integral of derivative of the first one 1, integral of the second one 1 minus x to the power of 50 whole to the power of 101 by 5050 between the limits 0 to 1. Between the limits 0 to 1. Again, I1 minus, if you put 0 and 1 here, 1 minus 1 is 0, 0 into is 0, so this part becomes 0 minus integral 0 to 1, 1 by 5050 into 1 minus x power 10 whole to the power of 101 is nothing but observe this is nothing but I2, isn't it? Of course, minus of minus is plus, therefore I2 is equal to I1 plus 1 by 5050 into I2. You bring I2 that side, so that it is I1 is equal to I2 into 1 minus 1 by 5050. What is 1 minus 5050? Is nothing but 5049. So I2 into 5049 by 5050. And we are asked to have I1 by I2. I1 by I2 is nothing but 5049 by 5050. So in this simplification, you are supposed to have 1 minus x to the power of 15 to whole to the power of 100 into x power 49 dx in the beginning itself. And we make use of that here. This is the matter. So what is I1 by I2? 5049 by 5050. That is it. Let us now consider the next problem. Integral minus pi by 3 to pi by 3. Pi plus 4x cube dx by 2 minus cos of mod x plus pi by 3. This is the given problem. Let us first decide divide this into two integrals, namely minus pi by 3 to pi by 3, pi by 2 minus cos of mod x plus pi by 3 dx plus minus pi by 3 to pi by 3 4x cube by 2 minus cos of mod x plus pi by 3 dx. Well, my dear, you please observe, this is surely an odd function. This is an even function. So the quotient of an odd function and even function is again an odd function. As this is an odd function, this integral becomes 0. What is the formulatical background for that? Integral minus a to a f of x dx is equal to 0 if f is odd. If f is an odd function, we could have had that beautiful formula in our hand. By making use of that, this integral vanishes. Moreover, you please observe, this is an even function, isn't it? Even if you put minus x in the place of x, there will be no change at all. Hence, this can be written as 2 into integral 0 to pi by 3 pi dx by 2 minus cos of mod x plus pi by 3. Isn't it? Mod x plus pi by 3 plus 0. Why? Because this is an even function. Why? If it is an odd function, it is 0, or this is equal to 2 into integral 0 to a f of x dx. If f is even, by the same formula we could have made use of. Now, my dear, you please observe that if x lies between 0 and pi by 3, mod x is nothing but x itself. Hence, it can be taken as 2 into integral 0 to pi by 3 pi dx by 2 minus cos of x plus pi by 3. X plus pi by 3. Let us name this as I dx. Okay, so we take interest in simplifying this. What happens to that? Let us now observe this. Let x plus pi by 3 is equal to t. Automatically, we may have to change the previous limits for x also. What are the limits for x? X equal to 0 and x equal to pi by 3, isn't it? X is equal to 0 implies t is equal to 0 plus pi by 3 is pi by 3, and x is equal to pi by 3 implies t is equal to pi by 3 plus pi by 3, 2 pi by 3. 2 pi by 3. Therefore, I is equal to 2 pi into integral pi by 3 to 2 pi by 3 1 by 2 minus cos t dx dt. I'm sorry. Two minus cos t dt. And this is a problem in one of the standard models taking tan t by 2 is equal to something, isn't it? Now, we shall use that procedure. Put tan t by 2 is equal to u. What is derivative of tan t by 2? 1 by 2 into secant square t by 2 dt is equal to du. This is nothing but 1 plus u square, isn't it? Therefore, dt is equal to 2 du by 1 plus u square. That is okay. What happens to the limits then? Also, what are the limits? Previous limits. T is equal to pi by 3 implies, what is meant by pi by 3? 60 degrees. 60 degrees by 2 is 30 degrees. Tan 30 is 1 by root 3. And if 2 pi by 3, then what happens to the fate of u? 2 pi by 3 by 2 is nothing but pi by 3. Tan 60 degrees. Tan pi by 3 is root 3. Therefore, come on, what is the now new shape of I? I is equal to 2 pi into integral pi by 3 to 2 by 3. Instead of 5 by 3 to 2 pi by 3, we use 1 by root 3 to root 3. What is dt? 2 du by 1 plus u square by 2 minus 1 minus t square by 1 plus t square, isn't it? Because cos t is nothing but 1 minus tan square t by 2 by 1 plus tan square t by 2. Well done. Let me multiply both numerator and denominator with 1 plus u square. This is nothing but 1 minus u square by 1 plus u square. If you multiply both numerator and denominator with 1 plus u square, this will be becoming 1 by root 3 to root 3, 2 du by 2 into 1 plus u square minus of 1 minus u square. 1 minus of 1 minus u square. Well, this is therefore integral 1 by root 3 to root 3. Numerator is 2 du by denominator is 2 ones are 2. Minus of minus 1 is 2 minus 1 is 1. 2 into u square, 2u square plus u square. It is 3u square, isn't it? 3u square. Hence, this is equal to 2 by root 3, no, 2 by 3 into integral 1 by root 3 to root 3 du by 1 by 3 plus u square. Look at that. It looks like 1 by a square plus x square. What is the integral of 1 by a square plus x square? 1 by a tan inverse x by a. Well, I like to remove the first two steps. Let us continue. In the previous steps, we have forgotten 2 pi. 2 pi. It is 4 pi by 3. Let me continue from there on. This is equal to 4 pi by 3 into 1 by a. This looks like 1 by a square plus x square. A square is 1 by 3. So 1 by a is 1 by root 3 tan inverse x by a between the limits 1 by root 3 to root 3. 1 by root 3 becomes root 3. Root 3 by 3 becomes, it is 4 pi by root 3 into tan inverse u root 3 between the limits 1 by root 3 to root 3 is equal to 4 pi by 3 into. If you substitute root 3 into root 3, root 3 into root 3, 3. So it is tan inverse 3. If you take 1 by root 3 into root 3 becomes 1 pi by 4. This is the answer. That becomes the answer. Please follow that. We shall make a move to deal with the next problem. The next problem before us is integral minus pi to pi 2x into 1 plus sin x by 1 plus cos square x dx. This is the given integral I. This is equal to minus pi to pi 2x by 1 plus cos square x dx plus minus pi to pi 2x sin x by 1 plus cos square x dx. I think you might have understood what I could have done. I have split this 2x plus 2x sin x, that's all. See, 2x by 1 plus cos square x, these are an odd function, you please observe. 1 plus cos square x is even, 2x is odd function by even, it is again odd function. So by the previous formula, integral minus a to a. If f of x is an odd function, it becomes 0. Accordingly, this is an even function. 2x is an odd function, sin x is an odd function, product of odd function and odd function is again an even function. This is an even function. 1 plus cos square x is an even function, therefore it is an even function. As it is even, we can write this as 2 into integral 0 to pi x sin x by 1 plus cos square x. This 2 is from here. This 2 is using the formula. Therefore, this is equal to 4 into integral 0 to pi minus x into sine of pi minus x. Sine of pi minus x is just nothing but sine x by 1 plus, even though cos pi minus x is minus cos x, as it is power 2 cos square of that, so it is cos square x. How can we get this step? Integral 0 to a f of x dx is nothing but integral 0 to f of a minus x. That is, I could have written pi minus x in the place of x. That's all. This is I again. Okay. This is I. This is I. This is I. Isn't it? You add those two. What happens? I plus I is equal to 4 into integral 0 to pi 1 plus cos square x is okay. Denominator pi minus x into sin x plus x sin x. What happens? If you get sin x as a common factor, pi minus x plus x is nothing but pi sin x. Therefore, it is pi sin x dx. Therefore, 2i is equal to 4 pi into integral 0 to pi sin x dx by 1 plus minus cos x whole square. I think you could have got the point. Why is it necessary to imagine cos square x as minus cos x? Well, my dear, you imagine minus cos x is equal to t in your mind. It is, if minus cos x is t, sin x dx is dt. dt by 1 plus t square, come on, what is dt by 1 plus t square? It's just nothing but, 1 by 1 plus t square is tan inverse t. That is tan inverse minus cos x between the limits 0 to pi. Between the limits 0 to pi. Well, what happens? It is tan inverse of minus cos x between the limits 0 to pi. Okay. This is 2i is equal to. Well, you take cos x, it is substitute the limits. If x is pi, cos pi is minus 1, minus of minus 1 is 1, tan inverse 1 is pi by 4. So this is 4 pi into pi by 4. 4 pi into pi by 4. Well, if you put 0, cos 0 is minus 1, tan inverse of minus 1 is minus pi by 4, minus of minus pi by 4 is pi by 4. Pi by 4 plus pi by 4 is pi by 2. So this is 4 pi into pi by 2. So this is 2 pi square. This is all 2i. 2i is equal to 2 pi square. Hence I is pi square. I is pi square. Hence the answer for this question is pi square. See? The main point here lies in the very first step itself. You are supposed to split into two integrals so that one particular part becomes 0, because it is an odd part, odd functional part. This is an even function. If you simplify, the answer will be pi square. Go through the problem. Let us go through the next problem. I is equal to integral 0 to 1 tan inverse of 1 minus x plus x square dx. Now you think of the problem. As it looks, if you make an attack directly, it becomes a tedious job to get it simplified. One thing you can do, if you have 1 minus x plus x square in the denominator, you can do something by getting converted into tan inverse x minus tan inverse y, like that, or something like that. But you see, here it is in the numerator. Okay, we shall change it. How? This is equal to integral 0 to 1 pi by 2 minus cot inverse of 1 minus x plus x square. Isn't it? Can you say okay for this? We already have tan inverse x plus cot inverse x is equal to pi by 2. Therefore, tan inverse x is equal to pi by 2 minus of cot inverse x with a suitable domain. And this domain 0 to 1 is of course suitable, no problem for that. Therefore, it is pi by 2 minus of cot inverse of 1 minus x plus x square. Any problem? I think you could have caught it. Tan inverse x plus cot inverse x is equal to pi by 2. So, tan inverse x is equal to pi by 2 minus cot inverse x. Well done. So that this is integral 0 to 1 pi by 2 dx minus integral 0 to 1 cot inverse of 1 minus x plus x square, isn't it? I like to write this as tan inverse of 1 by 1 minus x plus x square. Any problem? Cot inverse x and tan inverse 1 by x, they are one and the same. You can easily observe that. Okay, this is equal to, what is the integral of 1? It's nothing but x between the limits pi by x between the limits 0 to 1 minus, now you observe 0 to 1 tan inverse of, look here, I would like to write this 1 as x plus 1 minus x. Any problem? Minus x and plus x go away, leaving you 1, which is required and present in the numerator. Come to the denominator by 1 minus x into 1 minus x. See, minus x plus x square could be written like this. This is the plan which we could have got in the beginning itself. That is why we take interest to have this 1 minus x plus x square in the denominator. This is the benefit out of that idea. Okay, what is this? Between 0 and 1 it is 1, hence it is, therefore I is equal to pi by 2 minus integral 0 to 1. You observe, this is tan inverse A plus B by 1 minus AB is nothing but tan inverse A plus tan inverse B. Hence this is tan inverse X plus tan inverse 1 minus X dx. Okay, this is again pi by 2 minus integral 0 to 1 tan inverse x minus integral 0 to 1 tan inverse 1 minus x dx. Well, my dear, you please recollect one of the standard results in definite integrals. Integral 0 to a f of x is nothing but integral 0 to a f of a minus x. Even if you put 1 minus x in the place of x, this is nothing but tan inverse x. So these two are numerically equal. Hence, you can write this as pi by 2 minus 2 into integral 0 to 1 tan inverse x. Now we know that integral of tan inverse x can be obtained by integration by parts. How can it be done? Do you want to have the triangular format? Tan inverse x, x, 1 by 1 plus x square. This is the triangular format. Come on. This is equal to pi by 2 minus 2 into x tan inverse x minus integral of x tan inverse x minus integral of 1 by 1 plus x square into x dx between the limits 0 and 1. Okay, this is equal to pi by 2 minus 2 into x tan inverse x between the limits 0 to 1. I am substituting the limits here and here. Minus 2 into minus plus integral 0 to 1 2x by 1 plus x square dx. This is all I is equal to, isn't it? Now, you please follow these steps, keep these steps in mind. I would like to remove these steps, of course, to save this space. This is pi by 2 minus 2 into, come on, substitute the limits. If you take x is equal to 1, 1 into tan inverse 1, what is that? 1 into, what is tan inverse 1? Pi by 4. 1 into pi by 4, pi by 4. And if you take x 0, 0 into tan inverse 0 is again 0, plus, you can observe this, f dash x by fx is one of the standard formulae. F dash, see, the derivative of 1 plus x square is just nothing but 2x, isn't it? So f dash x by fx, what is the answer? Log mod fx, that is log mod 1 plus x square between the limits 0 and 1. As 1 plus x square is absolutely positive, therefore you need not have modulus sign there. Okay, what is going to happen? Pi by 2, 2 into pi by 4 is again pi by 2, plus, if you take 1 in the place of x, it is log 2. If you take 0, it is log 1. But log 1 is 0. These two will be cancelled. Ultimately, what is the final answer? Log 2 to the base e, of course. See, final answer is log 2 to the base e. We follow it. Let us look at the next problem. Integral 0 to pi by 2 sine of 2 nx into cot x dx. We are lucky, n is a natural number he has given. Let me name this as in instead of I. Okay, what do you mean by I5? Sine 10x into cot x. What is I6? Sine 12x into cot x. What is I2? Sine 4x into cot x. Like that. Isn't it? Yes. Try to get a plan. No doubt it is a very good problem. Well, the key point here is you please consider in minus 1. Why? You will have sine 2nx and sine 2 into n minus 1x. You are subtracting that, so that you will be having sine c minus sine d format, in which you have 2 cos c plus d by 2 sine c minus d by 2. Something transformation can be used. Okay. This is equal to integral 0 to pi by 2 sine of 2 nx minus sine of 2 into n minus 1x into cot x dx. Into cot x dx. Okay, this is equal to, as it is pre-planned, this looks like sine c minus sine d. What is that? 2 cos 0 to pi by 2, 2 cos c plus d by 2. 2nx plus 2 into n minus 1x by 2. If you get 2x out, n plus n minus 1 is 2n minus 1. Isn't it? 2n minus 1 by 2 is there. Therefore, it is cos of 2n minus 1 into x. This plus this by 2. 2 will go away. nx plus n minus 1x. What is that? 2n minus 1 into x. 2 cos c plus d by 2 into sine c minus d by 2. What is c minus d by 2? 2nx minus of 2 into n minus 1x. You get 2 cancelled. Again get x as a common factor. N minus of n minus 1 is 1. So it is sin x into cot x is there. I would like to write this cot x as cos x by sin x dx. You can cancel sin x. Well friend, what are you having? 2 cos of 2n minus 1x into cos x. Again, this looks like cos 2 cos a cos b. What is 2 cos a cos b? Cos of a plus b plus cos of a minus b. Isn't it? Therefore, this can be transformed again into, come on friend, 2 cos a cos b is cos of a plus b plus cos of a minus b. That is cos of this plus this. 2n minus 1x plus x. What happens? If you get x out, 2n minus 1 plus 1 is 2nx plus cos of a minus b. 2n minus 1x minus x. Isn't it? Cos of a minus b. What is it? Minus x minus x. That is 2n minus 1x minus x. That is 2n minus 2 into x. Dx. You observe it once again. It is sin c minus sin d. Sin c minus sin d. Okay. Next one. This is equal to, what is the integral of cos 2nx sin 2nx by 2n? Sin 2nx by 2n between the limits 0 to pi by 2 plus here cos of 2n minus 2 into x. What is its integral? Sin of 2 into n minus 1x by 2 into n minus 1x between the limits 0 to pi by 2. Observe it carefully. If you take pi by 2, 2 into pi by 2 is pi, isn't it? 2 into pi by 2 is pi, sin n pi is 0. If you take 0, already it is 0. Plus, if you take pi by 2, n minus 1 pi you will be having, even that is 0. Altogether this is 0. You see, is it I or in or anything? In minus of in minus 1. Therefore, in minus 1 is 0. Therefore, in is equal to in minus 1. Now, replace n by n minus 1. This is in minus 2. Isn't it? In is equal to in minus 1. Apply, go on applying like that. What you have, it is equal to I3 is equal to I2 is equal to I1. I1. Isn't it? What is I1? Sin 2x into cot x dx. Isn't it? Is equal to integral 0 to pi by 2 sin 2x into cot x dx. What is sin 2x? This is equal to integral 0 to pi by 2. No, I shall simplify this again. Follow up to that level. I like to remove some of the steps here in this direction. I continue the problem here. That is equal to integral 0 to pi by 2. What is sin 2x? 2 sin x into cos x into, what is cot x? Cos x by sin x dx. Isn't it? Therefore, this is 2 into integral 0 to pi by 2 cos square x dx. Cos square x dx. What is integral of cos square x dx? You can make use of Wallis formula. 1 by 2 into I0, that is pi by 2. Therefore, the answer is pi. So, in is just nothing but, pi by 2 is the right answer. Isn't it? Right. Integral cos square x is pi by 4. We know that 2 into pi by 4 is just nothing but pi by 2. Ultimate answer is pi by 2. You observe that. It's a beautiful problem. See, unless you get the idea of getting in minus of in minus 1, it might be tedious to look at the answer in a straight way. So, in that way, it is a special problem. You please follow that. A lengthier sentence has been given. Try to follow very carefully. A, B, C are three non-zero reals such that integral 0 to 1 plus cos power 8x into ax square plus bx plus c dx is equal to integral 0 to 2 1 plus cos power 8x into ax square plus bx plus c dx. Then ax square plus bx plus c is equal to 0 has a root in what interval? That is, he has given, of course, certain options. Open interval 0 to 1, open interval 0 to 2, open interval 1 to 2, none. Like that, he has given the options. In order to choose the options, you must be able to make a proper attack on the problem. As observe it carefully. Well, the proper plan to solve this question is, I like to define f of x is equal to integral 0 to x1 plus cos power 8x into ax square plus bx plus c dx. For all x greater than 0. Look here. Now doubt this is continuous and derivable. I like to observe this function on the closed interval 1 to 2. Undoubtedly, it is a polynomial function and it is a well-known function, continuous in its domain, no doubt, and derivable. Moreover, what is f of 1? Integral 0 to 1, this. What is f of 2? Integral 0 to 2, that. So, from data, f of 1 is equal to f of 2 is also there. Therefore, by Rolle's theorem, Rolle's mean value theorem, if you can use Rolle's mean value theorem, there is one C in the open interval 1 to 2 such that f dash C is equal to 0. Okay, then what is f dash C? What is the derivative of this? This product. This product has a root. You see, 1 plus cos power 8x cannot have a root in open interval 1 to 2. No doubt. Because cos power 8x is always less than or equal to 1. It can never exceed 1. Therefore, no question of getting a root for 1 plus cos power 8x in the open interval 1 to 2. No root of this equation exceeds 1. Therefore, this has no root in the open interval 1 to 2. The only alternative here is x square plus bx plus c is equal to 0 has a root in open interval 1 to 2. Why should you have like that? Because you could have denoted, rather defined f of x in this interval 1 to 2. So by the Rolle's mean value theorem, as all the hypothetical conditions of Rolle's mean value theorem have been satisfied here, including f of 1 is equal to f of 2, there is one C in open interval 1 to 2 such that f dash C is equal to 0. There is f dash x equal to 0 as a root. There is this lengthy equation as a root, but 1 plus cos power 8x cannot have a root at all in open interval 1 to 2. Hence, there is no other alternative. X square plus bx plus c is equal to 0 should have a root in open interval 1 to 2. So, it's a conceptual problem. Nothing to do actually. You may have to get the idea of defining f of x like this, then only you will be in a position to say the answer in open interval 1 to 2. That's it.